We're on Zoom, doing it that way, but I'm getting ready to cut the music so that we can actually go live without any interference. All right, guys. Let me go ahead and cut this off. All right, so I hope everybody is doing well today. Yesterday we did a lesson on thermodynamics, so we're going to continue that lesson today. So for those of you guys that are new, if you're new to Professor TK the Chemist Live, put a purple heart in the chat. If you are new to Professor TK's Live, put a heart in the chat. If you've been rocking with me since day one, when I started these chemistry lessons during the office hours at 12 noon, put a blue heart in the chat, okay? So if you've been rocking with me since the beginning, put a blue heart in the chat. If you are new to Professor TK the Chemist, put a purple heart in the chat. Now, what I'm doing today is we're going to be talking about Hess's law. All right, I see you, Steve. I see you. Okay. All right, and I saw someone else with a purple heart. Welcome, Marie. Hey, Kayla. Hey, Maya Money. So everyone that's coming in the building, welcome, welcome, welcome to Professor TK the Chemist Chemistry Office Hours, where I go live Monday through Thursday at 12 noon. Hello, Sweet Turkey Barbecue. So, hey, LaShonda. Hey, SYD. So I go live Monday through Thursday at 12 noon to give away free chemistry tutoring lessons to students who are on the struggle bus with chemistry. Now, just because you are struggling doesn't mean that you are in a bad position. I give away free tutoring so that you can get off that bad position and get on board with something better. So if you guys need additional help, by all means, come through. Thank you, Francine. So by all means, come on through. I'm going to be talking about Hess's Law today. So for those of you guys that need additional help, you got it right here with me, right here with me. So let me go ahead and put that on the screen. So for those of you all that need additional help, you'll know exactly what we're doing today. Okay, so give me 1 second. I want to make sure everything is working right. Because sometimes, there we go. Yeah. Okay, there we go. Yes, it is working properly. So let me go ahead and screen share. Okay, so all right, so today we're going to continue our lesson on Hess's law. He's Hess, tomato, tomato, however you want to say it. We're going to actually continue our lesson on that law today. And I'm going to show you guys, continuing to show you all some tips and tricks on how to actually make this a lot digestible. I know some of these students, whenever you're taking chemistry, you feel that this is a very hard thing to do, but it is, I'll say this, I don't want to make chemistry seem like it's as easy as 1, 2, 3 ABCs. But I do want to let you guys know that if you put in the work and you study your notes, even if you're studying 30 minutes a day, just a little bit at a time, you will be able to digest the information in a better way. I know so many students grapple at this lesson and they oftentimes struggle and they get discouraged. And some of you guys may be on the verge of wanting to withdraw. But I tell you, don't do that just yet. Unless you come and talk to me, and then I may be able to get you back on the right track. So before we start, let's make sure we go ahead and get our pens, our calculators, our paper. Of course, you guys stay hydrated during this live, and a sense of wanting to learn, because I'm here for you guys to make sure that you all are able to get what you need when you need it. Okay, I am a chemistry professor. So for those of you all that are wondering, who is this person? I teach chemistry. I've been teaching chemistry for 27 years. So I'm not new to this. I'm true to this. Okay, so if you guys are ready to start, let's go ahead and get started. With Hess's law, for those of you guys that are taking this right now, if you are in chemistry right now this semester, put a thumbs up. If you are in chemistry this semester, put a thumbs up. Put a thumbs up. Okay, very good, very good. Now, here's the thing though. If you are new to chemistry, is it difficult? Like, what challenges are you guys having in your chemistry class? What challenges are you guys having in your chemistry class? Because I want to know how we can make this better. Okay. How can we make your class better? Because I know so many times students are struggling, trying to figure out. Okay, Eric says, I teach high school chemistry, but don't teach this since most students are struggling with algebra. Can you put this on YouTube? Yes, it is on YouTube. I am live right now on my YouTube channel. Yes, yes, yes. Yes. Not being attentive. Okay. Okay. Yes, and I totally get what you guys mean. And in terms of the students that are struggling with Algebra 1, I totally get what you mean by that. I totally get that. Francine said a new way of thinking chemistry is a 360 on how we apply concepts. Yes, that's correct. That is correct. But I know that with a lot of students who are on that struggle bus, for some reason or another, students, if they don't have their math down pat, especially students who are if you are a chemistry teacher and you're teaching high school, I can see how that is a struggle. Okay, my YouTube channel is Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. Okay, Eric, you said they need the algebra help, but also a class like statistics that helps you understand what math means. Okay, yes, 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 yes. Statistics is one of those classes that it has its ups and downs. I remember taking statistics in grad school, and it was it was interesting to say the least. Yes, but for those of you guys that want to go back and look at the video, by all means, you can go on to my YouTube channel. And again, that's Learn Chemistry with Professor TK the Chemist. Learn Chemistry with Professor TK the Chemist. Now, I make sure and I try to make sure that I allow my students the opportunity to get chemistry help whenever they need it. But for those of you guys that are taking chemistry and you're like, my teacher just makes this stuff so hard and so difficult, I am your go-to person, okay? So let's go ahead and show you guys what we can do to make this easy. And Eric, we can talk offline if you need some further assistance with this as well in terms of what strategies I have. How long have you been teaching though? Okay, because I don't want to give an OG help if you've been doing this as long as I have. Okay, so those of you guys that are taking chemistry right now, if you come across things like this of what I have on the screen, I'm going to show you an easy way to make it digestible. Okay, those of you guys that are on YouTube, I can't see your comments, but if you put them in the chat, I can help you. Now, okay, this is your 10th year. Okay, excellent, fantastic, fantastic. So I teach college students, and a lot of times I know that there's a struggle with the math, but I try to break it down in the simplest way possible to make it digestible. So for instance, in a problem like this, where it says, well, first off, they're giving you some background information. They're saying carbon occurs in two forms, graphite and diamonds. The heat of combustion of graphite is negative 393.5 kilojoules, and that of diamond is negative 395.4 kilojoules per mole. Here's what you need to do, okay? They're telling you that they want the delta H, okay, for the conversion of graphite to diamond. So let me zoom in a little bit more so you all can see that. Basically, they want the reaction to look like this, graphite to diamond. But this is what they've given you. Let me tell you the easiest way to make this work. I'm going to go ahead and put all this down so I can have some space on the board. So you notice that the answer is right here. It's positive 1.9 kilojoules. This is important. I want you guys to see the answer so you'll know if you're on the right track. Oh, you're welcome, Katie or Kadi. You're welcome. Or Kadai. Sometimes when I see y'all names, I don't be wanting to mess them up, but yes. All right, so because I want the chemical reaction to say the carbon of graphite to diamond, I'm going to put the first reaction here first. So this one right here, this is reaction number 1, and this is reaction number 2. So number 1 and number 2. I'm going to put number 1 first, and let me change the color to make it easier for you guys to see this, okay? So you've got C graphite plus oxygen produces carbon dioxide, and the delta H is equal to negative 393.5 kilojoules. Okay, so I'm going to zoom out a little bit. Now, what you need to do, whenever you do a problem like this, because I wanted to say C graphite first, I wrote that one first. Because they want diamond on the other side, meaning the product side, I'm going to reverse this second reaction. And if I reverse the second reaction, guess what? This sign here, that negative sign, is going to change into a positive. So I'm going to rewrite the second reaction and put carbon dioxide on this side, on the reactant side this time, and then put C diamond on the product side plus oxygen. Now, y'all, I write pretty big, so I don't have space to write in the delta H for this one right beside it. So I'm going to write it underneath it, okay? Now, remember, because it was initially negative, it's now going to become positive, 395.4 kilojoules, okay? Now, what we're going to do, we're going to actually cross out things that are the same on either side of this reaction, okay? They're on opposite sides, excuse me. So carbon dioxide is on this side, on the left side, and carbon dioxide is on the right side in the first reaction. So I cross both of those out. Oxygen is on the left side in the first reaction, and it's on the right side in the second reaction. All you're going to do now is write what's left over. C graphite and C diamond. So I'm going to go ahead and write that down here, okay? So I'm going to write C graphite yields C diamond. And as you guys know, pressure makes those diamonds. Some of you guys may be going through a lot of pressure this semester, but guess what? The diamond in the end is that grade of saying that I don't have to take chemistry over, okay? Now, what am I going to do? I'm going to take these two right here, the delta H's. I'm going to add them, and I put that in brackets, add them, okay? Hey, Tori, I ain't seen you in a minute. So I've got the negative 393.5 plus 395.4. Now, when I add those together, you see it comes out as 1.9. Now, those of you guys that are on YouTube, you will not see me calculating it out because my camera is off, but the answer is positive 1.9 kilojoules. Isn't that the answer that you guys see right here on my answer chart that I'm highlighting in yellow? That is the same answer, okay? So Hess's law is that simple. You do not have to overthink it. What you're basically doing, guys, is flipping the reactions to solve for what you want and canceling the like terms out. And sometimes you may have to use coefficients to make the process work. Now, what do I mean by coefficients? Let me show you. All right. Hey, Amelia, I ain't seen you in a minute either. Oh, thank you, Tori. Y'all are so sweet. I love y'all. Yes, thank you so much. So, Amelia, if this is the homework that your chemistry teacher gave you guys over breaking, you're struggling, make sure you reach out to me, okay? If you need some extra help, make sure you guys reach out to me. Now, on this next problem, okay? Because, I'm going to give y'all a challenge. Light Mike said, I miss these. What you miss about it? What you miss about it? Now, here's something else I want you guys to be aware of. Sometimes your teachers may not give you guys all of this information here. They may force you to try to figure everything out. But in this part of my book here that I took out so you guys can see it, it says calculate the heat of formation of pentane, which is C5H12, using the information of heats of formation, which I've already provided you guys with right here, and the information of heats of combustion in table A5. Solve by combining the known thermochemical equations. Now, I know that's a mouthful, right? But here's the deal. You've got the first reaction here, okay? You've got the second reaction there. You've got the third reaction here, okay? So again, let me highlight them so you can see what I'm talking about, okay? Here's your first reaction right here. And let me highlight the second reaction right here. Oh, for some reason, the pink ain't working. Here's your second reaction right here. And then here is the third reaction, okay? I color code everything, y'all, because sometimes you got to see a transition in those thoughts, okay? You've got to see the transition in those thoughts. So the first reaction provided you with the heat of formation, and the second reaction did as well as the third reaction. So here's the thing, though. When you see these numbers, okay, in order to get rid of those fractions and put the numbers that you need, you're going to have to use coefficients to do so. Now, I'm going to put this one in well, I thought I was going to do it in purple. I'm going to do it in orange, okay? So they want you to calculate the heat of formation based on the one that's in orange, okay? So watch what I do. This is going to take a little bit to do because there's a lot that I've got to write out. And because I'm writing everything out for you guys so that you can see it from top to bottom, it's going to take some patience, okay, to work with me. So what I'm going to do first, in order to make this process work, okay, let me see if I can make my little pencil a little bit smaller. I'm going to write CS, okay, carbon plus oxygen, producing carbon dioxide, okay? The delta H was negative 393.5 kilojoules per mole. Okay. I know, right? Iconic? Yes. And Amelia, this is why you got me as your sidekick, because I can help you. Okay, you got me as your sidekick. All right. The second equation, it has H2 for hydrogen plus, and there's a fraction, but don't fret with those fractions. They're just there, okay? They're just there. Don't worry about those fractions. And the delta H, again, is negative 285.8 kilojoules per mole. You're welcome, Leah. Oh, love Amelia. And then the last one, the one in green, I'm going to flip that one, okay? Let me zoom in so y'all can see why. Notice how C5H12 is on the right side. That's what they're wanting you to solve it for in that particular way. So I'm going to flip the one in green. I'm flipping the one in green because they want the C5H12 on the product side. So I'm going to flip the one in green. And because I'm flipping the one in green, that means this sign here, that negative sign, is going to become positive. Okay? It's going to become positive. So watch what I do when I flip it. I'm going to basically write 5 CO2 plus 6 H2O produces C5H12 plus 8O2. And my delta H, y'all forgive me for writing this so sloppily, but I'm going to write it as small as I can. It becomes positive 35.6 kilojoules per mole, okay? All right, now I'm gonna zoom back out, y'all. I'm gonna zoom back out, okay? So that you guys can see me do the whole thing in one piece. Now, here's the thing though. I've got to figure out how to get rid of the carbon dioxide because we don't need that in our equation, okay? I got to figure out how to get rid of that one. So here's the thing. I also need 5 carbons. If you see the one in orange, there is 5 carbons there. So you know what this means? I've got to multiply this entire formula right here, including the delta H, by 5. I got 5 on it. Okay. I got to multiply it by 5. So here again, here's the reason why. Because the coefficient, in order to get rid of the carbon dioxide, I've got to have 5 of those on the right-hand side. And also because in the orange formula that we need to calculate the delta H for it, there's a 5 for the carbon. So that's why I have to multiply the entire formula by 5. So this is why I say, please be patient with me because I got to write all this stuff down again. Okay, so I'm going to write this again, but I'm going to rewrite the new formulas now with the correct coefficients. So I've got 5 carbons here plus 5 oxygens plus 5 carbon dioxides. And I had left off the G initially. And then my delta H is going to be equal to 5 times the negative 393.5 kilojoules per mole. Okay, that's for the first one, okay? That's for the first one. I am going to keep the second reaction. That one doesn't change. So I'm going to write here H2 plus 1/2 produces H2O liquid. Delta H is equal to negative 285.8 kilojoules per mole. Okay, Dio, I'm going to show you, or Dio or Dio, I'm going to show you. It's not that hard. I promise you. It's not that hard. Matter of fact, let me show you. Let me tell you what's going on. So the question, YouTube, was, what do we do with the fraction if we don't change it? Excellent question. You do nothing, okay? You do nothing. And let me tell you why. That 1/2, that 1/2, that 1/2, if I'm gonna do the little quick math underneath it, but I'm gonna erase it so you can see what I'm talking about. And because you're a visual learner, I'm sure like I am, let me show you what I mean. Okay, so what you're gonna do, if you take that 1/2 and you multiply it times 2, guess what those 2's are gonna do? They're gonna cancel out and you're left with 1. That's just like saying I have 1 oxygen here on the left and I've got 1 oxygen here on the right. Okay, that's what happened. That's what happened. Okay, so 1/2 times the O2 is 1 oxygen. It leaves you with 1 oxygen. Amelia, I actually have them now on YouTube. So I'm actually live on YouTube. Yes, I am live on YouTube right now. So that way you can go back to my YouTube channel to get this. Yes, ma'am. Yes, ma'am. Hey, Z. Hey, Zena. All right. So now what I'm going to do, I'm going to keep the bottom equation too. Okay. I'm going to keep the bottom equation and you guys are going to watch something transformational happen. I've got 5 carbon dioxides plus 6 waters producing C5H12 plus 8 oxygens. Now, again, like I said, okay, Shanice, you can do virtual tutoring with me. Okay. Yes, you can do virtual tutoring with me. Hit that link in my bio and I got you. Okay. So right here, the delta H, I know that's, again, I'm going to have to write it as small as I can. That's positive 35.6 kilojoules per mole. Okay. 35.6 kilojoules per mole. Now, those of you guys that have been asking me, what do we do with those fractions? What do we do with these numbers? Let me show you. We're getting ready to cancel them out. Okay. Cancel, cancel, cancel. So I'm going to take the carbon dioxide that I have here, the 5 CO2s, snatch that away with the 5 carbon dioxides at the very top. And let me put a different color so you all can see that, okay? So I'm going to cancel out 5 carbon dioxides with the 5 carbon dioxides here. I'm going to also cancel out the oxygens. And let me tell you why. You remember when I did the little math and I said that 5 oxygens here, okay? You see the one in orange, right? This one right here plus 1 oxygen here is 6. I know y'all are like, what? I can't understand that. Remember, 1/2 times 2 is 1. So 5 plus that 1 oxygen gives me 6. And guess what? That's going to allow me to knock out my oxygens on the other side, okay? Again, I know you guys are thinking, oh, this just looks so complicated. But don't worry, don't worry. I'm going to show you. I'm going to keep moving so y'all can see what I'm talking about, okay? Because like I said, I can show you better than I can tell you. But you're probably saying, well, wait a minute. If you got 6 right here, how am I going to knock it out with the 8 over here? Well, you're going to have to readjust. And let me show you why. You see this 6 right here, the 6H2O, but you only have 1 H2O right here. You're going to have to multiply this formula by 6 also, okay? So you're going to have to multiply this formula by 6 in order for you to knock out the 6 waters in this third reaction with the one that's there. And I know it looks confusing as a mug, but y'all, I promise you, you just take one reaction at a time, okay? One reaction at a time. So now I'm going to still keep the one in orange the way it is, okay? So I'm going to come down here and write it out one more time. 5 carbons plus 5 oxygens produces 5 CO2. And I'm just rewriting it so you all can see why. I'm not going to make this confusing for you guys, okay? Because I want you all to understand that if you take your time when you're doing this, it won't be that bad. Now, I'm not going to write the unit in there because of space, okay? I'm not going to write the units. Now, the next one, I'm going to write that as well. The 6 in front of H2 becomes 6 hydrogens. And then that 6 times 1/2 becomes 3 oxygens. And then the 6 for the water, H2O. And then my delta H is 6 times that negative 285.8. Okay? Then I'm going to still keep the bottom one, okay? 5 carbon dioxides plus 6 waters produces C5H12 plus 8 oxygens. And again, your delta H, like I said before, is I have to write it really small, okay? It's positive 35.6. Okay. Now, here's what you've got, guys. Here's what you got. And that's why I preface this by saying, please be patient with me, okay? Because there's so many steps. And this is where students kind of get discombobulated, but you shouldn't. You should just breathe in and breathe out and just watch what I do. Like instead of writing it while I'm writing it, just watch how I do it, okay? I tell my students that all the time. Don't write while I'm doing it. I leave it up long enough for you guys to actually write it in. So watch what we do when we cancel things out. Again, we're going to cancel out the 5 carbon dioxides like we did before, okay? Now, you've got 5 plus 3 oxygens here, okay? 5 plus 3 gives you 8. And guess where your other 8 are? Right here. I canceled them out. You've got 6 H2Os there. Cancel those out with the 6 H2Os there as well. Are we done? I think we are with the cancellations. So now what you're going to do is write what's left over. So what's left over, I'm going to highlight in yellow, okay? This is left over. So you're going to write 5 carbons plus 6 hydrogens to give C5H12. 5 carbons plus 6 hydrogens. And I know that looks funny. Let me rewrite that in parentheses so y'all can see that. To give C5H12. And this balances out 5 carbons on both sides, 6 hydrogens on both sides. And remember, this was the equation that we wanted. If you go back up here in orange, this is what we wanted. Let me zoom in so y'all can see. We wanted 5 carbons plus 6 hydrogens to give us C5H12. Now, let me zoom out. Why? Because I'm going to have to now show you how to get the final answer, the delta H of all of this information that we did before, okay? So let me show you guys what we're going to do. We're going to take those delta H's over here, and we're going to add them up. Now, because it is so many of them, I'm going to write them down here in this space because I don't have enough space to write them out, okay? So I'm going to write them right here so that you guys can see that. The delta F's, I'm writing them all down right here, okay? So the top one, the first one here that I had, that 5 one, I'm going to put that here. That was 5 times negative 393.5 plus the second one, 6 times negative 285.8 plus the last one, 3535.6. That was the heat constant here for the C5H12 formula for the third reaction. That was the heat concentration value. Okay, let's plug these into our calculator because it is a lot. 5 times negative 393.5. You're welcome. I get negative 1967.5 minus 285.8. That's negative 285.8 times 6. And I get 1714.8 plus 3535.6. Okay, here we go. We got to put all these numbers into the calculator again. 1967.5 negative minus 1714.8 plus 3535.6. And we get 146.7 kilojoules per mole as our final answer. Okay, that is our final answer here for this particular problem. See, I got to show you challenging problems because your teachers are going to challenge you along the way. This is not one that you should be afraid to run from, okay? You should not run from this one. You should actually do this problem. Like you're leaving money on the table when you take a problem like this and say, oh, that's too much work. I'm just going to skip it. No, you should not skip it. You should still attempt to do all these steps. And it's really all about canceling out like terms, rearranging certain formulas or reactions to get what you need, putting coefficients in front of them. and just calculating and totaling up everything. It looks intimidating at first because you got all these letters and numbers trying to figure out what to do. But once you get started, like some of you guys have said, it's fun. Yeah, it is a little fun because all you're doing is like the algebra part. Like I think it was Eric that said that earlier. Okay. So this one was easy because that was straightforward. You didn't have to really do much to that one. This one, yeah, it was a lot. And with Hess's law, you do take up at least a sheet or two of notebook paper. Okay. Now, let me also say this, okay? If your teachers give you a chart, such as what I have on the screen, and they tell you to determine if it's going to be an exothermic reaction, endothermic reaction, or, like what can you say with all this? Let me also give you some other tips too. If you have a negative delta H, that is an exothermic reaction. That means you are releasing heat. You're releasing heat. So in this case, this was actually positive. So this was endothermic, okay? This was endothermic. So if your delta H's are negative, they are exothermic. If they are positive, they are endothermic, okay? So be aware of that, okay? Be aware of that. Endothermic is positive. That means you are absorbing heat. You're consuming it. You're taking it in. Exothermic means you are releasing. Also, you may have to do something with delta S and delta G. Now, you're probably saying, okay, well, what do you mean by that? You're talking about enthalpy, entropy, and free energy, okay? Enthalpy, entropy, and free energy. Having disorder versus order, okay? So, if you have a delta G that's always negative, these are going to be some other variables that you can actually consider right here, okay? Your delta H value will be negative. Your delta S will be positive. That means your delta G will always be negative. If your delta H is negative and your delta S is negative, that means your delta G will be negative also, but at a lower temperature. Just think, because you're multiplying these numbers out and adding to a certain extent, this is how you can kind of predict this other side too with your delta G. However, if your delta H is positive and your delta S is positive, then your delta G is negative, but at higher temperatures. And if your delta H is positive and your delta S is negative, then your delta G would never be negative. So let's do a problem like this so you all can see what I mean, okay? Here's an example right here. Let me zoom in so you all can see it. Okay, for the reaction, this is what they're giving you. NH4Cl produces NH3 plus HCl at 298.15 Kelvin. Your delta H is 176 kilojoules per mole, and your delta S is 0.285 kilojoules per mole Kelvin. Calculate delta G and tell whether this reaction can proceed in the forward direction at 298.15. Now, again, you're probably wondering, say, what now? All right, let me tell you. You've been given delta H and delta S and the temperature. They want you to calculate your delta G. So I'm going to show you guys how to do that. The formula that you're going to use is quite simple. Delta G equals delta H minus T times delta S. Again, your delta G is what you're looking for. Your delta H they gave you the temperature, which is 298.15 Kelvin, and your delta S is 0.285 kilojoules per mole Kelvin. All you guys are doing is plugging in the values. So delta G is equal to 176 kilojoules per mole minus the temperature that they gave you was 298.15 Kelvin times your delta S 0.285 kilojoules per mole Kelvin. Now, as you guys can see, we're going to cancel out these like terms. I'm canceling out the kelvins because you need to consider that your final answer has to be in the same unit, okay? So what I'm going to do is write out 176 kilojoules per mole minus, okay, multiply these two numbers right here. The 298.15 times 0.285. And you get, and we only need 3 significant digits, 84 point, I get 84.97. So I'm going to say 85.0 right there, okay? 84.97 gives me 85.0 in terms of 3 significant digits, kilojoules per mole. And now all you have to do is subtract those two numbers. 176 minus 85 gives me 91 kilojoules per mole. Now, the question is whether this reaction will proceed in the forward direction. Let's find out. Our answer here is positive 91. Positive 91. So let's go to the chart to determine that. Okay, because it is positive, our delta H, let's go back and look at our numbers. Our delta H was positive. Our delta S was also positive, okay? And our delta G was positive, but right here it says it's negative at higher temperatures. So what can we say about this? What can we conclude about this? It tells us that this reaction is not naturally occurring in that direction because remember, it says it would be negative if you have both things that are positive. But in this particular case, because our delta G is positive, you can state that this is not naturally occurring. So it will not proceed in the forward direction. Okay? That's it. We've got one more. One more. One more. You're welcome. You're welcome. So let's do this last one right here. However, in this particular problem, they're wanting you to look for your temperature. So you see, you can be given a formula, okay, like this, delta G equals delta H minus T times delta S. But all you have to do is flip this in order to solve for your temperature. And you know what? Let's try to figure that out. How would we get our delta, our temperature in this particular process? What can we do to get our temperature? Well, watch what I'm going to do now, okay? I'm going to bring the delta H to the other side. So I'm going to subtract the delta H. So that's going to be brought onto the other side, okay? So I've got delta G minus delta H. They're together. And I'm just going to cross out my delta H here, okay? Because I don't need that one anymore. And what's left over is negative T times delta S. Now, remember, we're trying to get the temperature. So I am going to divide this formula here by delta S, okay? by negative delta S, because we don't want to have that negative sign over here. So I'm going to divide it by negative delta S so that we can, again, cancel out our like terms. So now you're left with your temperature, okay? You're left with your temperature. So I'm just going to rewrite the formula and say that because we're looking for the temperature, it's equal to delta G minus delta H over negative delta S. And so now all you have to do is plug in the numbers that they gave you here, but you would also have to go and look at your chart to find your delta G, because they did not give you the delta G in this process. They only gave you delta H and delta S. You were missing delta G, okay? So we'd have to refer to a chart. And I talked about this chart yesterday. So let me actually share that chart with you guys so you can see what I'm talking about, okay? So this was the chart that we were talking about from yesterday. Let me see if I can scroll and find. Yes, there we go. This was the chart from yesterday, and it was dealing with bromine here, okay? And since that equation from the previous one that we were talking about dealt with bromine, okay? Right here, as you guys can see, since it's bromine liquid to a gas, it's 0. See that number right there is 0. 0. So because it is 0, okay, so you guys can see that right here. It is 0. What we're going to do, go back to the other screen that I had right here. And for my delta G, it's just going to be 0. So basically that G is going to go away. I mean, you could put 0 there if you wanted to, but nothing is going to really be in its place. So I'm just going to put 0 there just so y'all can see that, minus the delta H in this problem was 31.0 kilojoules per mole divided by negative delta S, which was 93.0. And that one says joules per mole Kelvin. Right here, okay? So you guys can see that over moles Kelvin. And now I'm going to pause this for right now. And I'm actually going to pick back up on this tomorrow. And here's why. This is going to take me a little time to do. But what I can tell you guys, we're going to pick back up on this tomorrow. But what I can tell you is that you're going to have to get rid of your joules here. Okay? Your joules must be converted into a kilojoule. And because this is going to run me over my time, I will pick back up on this one tomorrow, okay? And we only have 5 people left in the building anyway, from what I can see on my end. So this would be a great time to pause, my YouTube family, pause, and we're going to pick this back up, okay, on tomorrow. All right, because this is going to take me a little time to actually go through and do, but I did want to at least give you a head start. I will be on tomorrow at 12 noon. I go live Monday through Thursday, 12 noon Eastern Standard Time. I am on the East Coast, so I am live at 12 noon Eastern Standard Time, 9 a.m. for the Pacific folks. What's that? 10 a.m. for, what's that, the Mountain? And then Central Time is 11 a.m. So 12 noon, okay? 12 noon, 12 noon. All right, guys. Thank you guys so much for joining. Yes, you're welcome. You are so welcome. And again, this video will be up on YouTube. It's up there right now. You have a great day as well. You have a great day as well. Have a good one, guys.